Hello everyone, thanks for joining us. And today we're going to talk about ELK stack. And our speaker today is Marian, and he will tell you how to store and analyze logs with ELK stack.
Yeah, hello everyone. Nice to meet you all here. Hopefully this session will be very helpful and interesting for you. And today, as already mentioned, we will talk about ELK stack. So let me firstly talk a little bit more about myself. My name is Marian Fediev. As already mentioned, I am working as lead data software engineer at PAM. Also, I'm performing a role of resource manager. And today's agenda. Firstly, we will talk about ELK stack. And after that, we will talk about everything that included into them, including Elasticsearch, what does it mean full text search, what's the architecture of Elasticsearch, main concepts, one more component called Logstash, why do we need logs, how does Logstash works, one more, Kibana, analytic layer of ELK stack, and different kinds of dashboards. Also, in the end of the session, we will have a small demo session. I will show you how exactly Elasticsearch and Kibana looks like and how you can work with that. So let's start our talk. Let's start from the beginning. What does it mean ELK? ELK consists of three major open source projects, three major, I would say, technology or framework. The first one is Elasticsearch. It's a search and analytic engine. Also for visualization purpose, we are using Kibana. It lets our users visualize data using charts, graphics, dashboards, or any else. I will show you a little bit later. And also we can have one more component here called Logstash. What does it mean Logstash? Logstash server-side data processing pipeline that ingest data from multiple sources and can transform that filter and after then send it to Stash like Elasticsearch. Basically, when we are talking about these three components, so all of them are working together. And for Elasticsearch is using for storing, for searching in the data. Logstash is using as an intermediate step when we are trying to filter our data, when we are trying to find exactly the data that are, let's say, useful for some business analytical purpose. And Kibana tool that can visualize our data, that can build dashboards in near real-time manner. What does it mean near real-time? It means that the data, when we store data in Elasticsearch, we don't have a lot of, let's say, latency. We have high throughput, and we can visualize this data after a couple of milliseconds. And everything that we stored, we already can show it. Show to the clients, show to the business, show to our stakeholders or customers that are using it. So let's continue and to talk about these components a little bit deeply. The first component, the major components here is Elasticsearch. What does it mean, this Elasticsearch? What it is? Basically, it's distributed. What does it mean distributed? I hope some of you already should know that distributed means that it's, let's say, one logical part, but a lot of physical parts. It means that we are using a couple of physical nodes, a couple of physical servers meshing, but as for user purpose, for development purpose, we are working with all this stuff together as a one logical part. Also, it's a RESTful search and analytics engine based on Lucene library. It's capable for storing, searching, analyzing pretty large volume of data in near real-time processing. As I mentioned before, what does it mean near real-time? We don't have a real time here because we still have some latency. We still have a couple of milliseconds between data is presenting in Elasticsearch, and we can visualize or work with this data as well. Also, Elasticsearch provides us a scalable solution for full text search. We will talk about what does it mean full text search a little bit later. by breaking our data into some kind of smaller unit called shards, which can be distributed across multiple nodes in the cluster. Also, Elasticsearch can perform other type of search and analytics, such as aggregation or using some kind of geographical search. We also will talk about some graphics based on map using Elasticsearch. And one more thing, Elasticsearch provides a flexible and pretty powerful query language called Query DSL that allows our users to construct pretty complex query and filters and work with this in dashboards or just using Elasticsearch as a storage layer here. So we talked a lot about full text search. What does it mean? Its ability to search for words or phrases within the full body of text in documents or datasets. Essentially, for applications that requires efficient and accurate search capabilities, such as e-commerce website or search engine, or any kind of big data solution. For example, when we are talking about Google search, they also built on top of full text search to find especially that requests or websites that we would like to work with, we would like to see when we write some comments and we click on the search button. Let's talk a little bit more about architecture of Elasticsearch. Basically, when we are talking about Elasticsearch, we are talking about clusters. Cluster consists of nodes. In nodes, we are storing indexes. As you can see here on this chart, we have cluster as a node. Nodes are consist of indexes, but also index can be separated into shards. And inside this index, inside these shards, we have documents. It's a simple point of our data, single point of our data. And let's be more specific about this component, about this architecture. What does it mean nodes? As you can see here, we can have one master node, the major nodes here, main nodes here. But we also can have a lot of nodes with some replicas. About replicas, we will talk again. So Elasticsearch contains of one or more nodes. We also can have cluster contains of just single node that works together and form on a cluster. Each node is a separate instance of Elasticsearch that can run on a separate physical or virtual machine. In many cases, it's not the rule that one node is one physical node machine. In some cases, when we have pretty, let's say, high machine with very high resources, we can divide this physical node into a couple of virtual machine and separate Elasticsearch node inside this virtual machine. Also, nodes can be added or removed from the cluster dynamically, which allows the cluster to scale horizontal as needed. We can scale out if we need these resources and scale down in case we don't need these resources anymore. And also, Elasticsearch provides us a mechanism for balancing the distribution of data across nodes and ensuring that high availability in the event of nodes fail. What does it mean high availability? It means that working with some kind of technologies, working with some kind of systems, we can provide the guarantee that our system will be working and our data will not lose. And we know that at any single request to our server, we will receive some feedback or receive some results here from that. Cluster. In the previous section, we already talked about cluster, but here we more specific about Elasticsearch node. The next part is cluster. What does it mean cluster? Elasticsearch cluster, it's a group of one or more nodes that work together to provide search and analytic capabilities. As you can see here, we have a couple of nodes and all of them included into one single cluster. A cluster can be consist of nodes that perform different roles. It could be data nodes, it could be master eligible nodes, it could be coordinator nodes. It depends on the needs for these nodes, for this cluster, what we need to use, for which purpose we need to use this node. Also, each node within a cluster has a unique name. It's very important because depends on the unique name and configuration, we can avoid conflict within other node within the single cluster. And as I mentioned here about different role of nodes, let's talk about it more in more detailed way. Basically, there are three main roles that nodes can perform in Elasticsearch cluster. The first of them is data nodes. It's nodes, it's physical machine, it's physical server that contains data, that stores data and performs with this data. But also we can have, for example, master or master eligible nodes. What does it mean? It's some kind of, let it be single point of truth. When we have separate node, separate physical machine, that are responsible for meta information and responsible for, say, managing our clusters. Also, we can have coordinator nodes that are coordinate between master node and data node as well. By the way, we can have another type of nodes that are responsible for some another, let's say, task or operations. It could be ingestion nodes, or it could be machine learning nodes. What are the machine learning nodes? It's a type of nodes that are more suitable for working with machine learning algorithms. It means that inside this node, we have already installed a lot of libraries. These nodes are more suitable for, let's say, high processing of the data and build some kind of models using machine learning algorithms. By the way, one node, single node, can perform multiple roles, depends on needs of the cluster. For example, node can be both data node, so storing the data, and master eligible node at the same time. In case we are having just single node cluster, this node can perform a couple of roles. It, by the way, would be data node, it also would be master node, and it also would be some kind of coordination or ingestion or maybe machine learning nodes as well. When we create our cluster, we should specify what roles would be to these nodes. And in case we don't specify anything, by default, this node will be data node. In case we need to specify a couple of them, in configuration, we need to specify that what role will be for this node. Okay, this is clear, I suppose. And let's move on. Let's talk a little bit more about main components or main concepts. As I mentioned before, our Elasticsearch have cluster, and this cluster contains indexes, documents, charts, and replicas. Let's talk about all of them a little bit more. For concepts, for first abstractions, I would say it's document. What does it mean document? Document in Elasticsearch is a JSON data object that stored and indexed within an index. Basically, we have some kind of just JSON with names, with some kind of attributes, and each document in Elasticsearch is defined by unique ID, which is assigned automatically or can be specified by the user. As you can see here on this example, on the left side, we have JSON, the documents that we already pushed to the Elasticsearch. But on the right side, we have the JSON that are stored in Elasticsearch. Elasticsearch itself added some kind of meta information. Its index, what index for this document, its type of this document, its ID, versioning, because we can have a couple of versions of our document, sequence number, primary time, and source. Source is the data itself that we push it to the document. Elasticsearch also provides several mechanisms for indexing and searching the documents, including the use of inverted indexes and full text search capabilities. So the next part of our abstraction is indexes. What does it mean, indexes? So basically, Elasticsearch stores data as document, but a set of document contains is combined into index. It's grouped into index. So we can have some different indexes for different purposes. For example, we can have people indexes where will be stored all information about some people information from websites, from logs, or etc. It could be department index that will contain documents related to different departments and their information. Also, to work more in effective way with indexes, sometimes when we store a lot of data, a lot of information within the index, sometimes we need to create a separate index per some period of time. For example, it could be a separate index per day, and every day we will have the same people index, or it could be orders index, or it would be much better because we will store all information about orders in Elasticsearch. And on top of this information, we are creating indexes. It's some kind of orders. But this index every day will be increased. We will add more and more information inside this index. That's why it's better to create separate index per each day, or maybe per week or month. That means that we will contain some part of the data in separate index. But after that, we can use all these indexes as one single logical part in Kibana or maybe in other systems. So one more time, let's talk about indexes. Index in Elasticsearch, it's a logical container for one or more documents that share the same structure and properties. By the way, to store data in index, we need to send the same structure JSON. In case some of our JSON don't include some kind of information, we need to set some default value or just set null or empty strings there. Each index in Elasticsearch is identified by unique name. We need to specify this unique name, which must be in lowercase or cannot start with an underscore. It's some limitation on technology level. Indexes can be thought of as table in relation database. As we are talking about databases, index some kind of table. We could represent our index as a table, but document represents his single row inside this table. The number of indexes in a cluster can be limited by available resources. So it means we are not have possibility to create as much indexes as we want. We have some rules that indexes will be, let's say, limited by the resources that we are using in our cluster. Memory, disk space, storing associated documents, etc. Elasticsearch also provides several mechanisms for creating and managing these indexes, including the index API. It also allows you to create, delete, and manage indexes itself using some kind of graphic user interface or command line interface as well, and the mapping API, which enable you to define the structure and properties of the document within the index. The next portion of abstraction of Elasticsearch is sharding. What does it mean, sharding? So sharding is the process for dividing large volume of data into smaller one, more manageable units called shards, which can be distributed across multiple nodes within the cluster. Basically, we create our index. And as you can see here in this example, index has size around 1 terabyte. But for Elasticsearch, we are using cluster, contains of 10 physical nodes. And each of these nodes has only, let it be a half of terabytes of resources. And basically, in general, logically, we can't store this large index within single node. That's why we need to logically and physically as well divide our index into smaller chunks and save this chunk to different physical machine. It also helps us in replication as well. Elasticsearch provides several benefits of sharding, including improving search, indexing performance as well, increasing scalability, and fault tolerance. Fault tolerance means in case we are lose the connectivity to one of the nodes in Elasticsearch cluster, we will have a separate copy of this data of the shard on another node, and we can continue working with this data as well. Shard can be divided into two main, let's say, types: primary shard and replicas. Primary shard is the initial copy of the data. It's let's say it's major copy of a data, and replica shards are copy of the primary shard that are distributed across the nodes in the cluster from improving fault tolerance, high availability, and provide the possibility to our system to read this portion of the data in case we lose access to the main portion of the data. And here we're also talking about replication inside Elasticsearch. What does it mean, replication? As you can see here on this picture, we have Elasticsearch cluster, for example. And this cluster contains of 3 nodes, nodes 1, nodes 2, and node 3. And you can see that our data, we have replica 1, primary 1, let it be replica 1, replica 1. And we have, let's say, copy of our data in different nodes, in different physical nodes. And it helps us to provide high availability, as I mentioned before. Also, on the another node, we have primary 2 and primary 3. Three portions of data. And in case we, let's say, lose access or connectivity to node 2, our Elasticsearch, our system, will be able to read this portion of the data from, let's find it from node number 1 or node number 2. In case we lose access to 2 or 3 nodes, we will have this data on node number 3. We have 1 portion of the data, 2 portions of the data, and 3 portions of the data. And just to repeat my word, what does it mean replication? Replication is a process of making copy of data and distribute them across multiple nodes within a cluster for improving fault tolerance and availability. Basically, replica shards are a copy of the primary shards that are distributed across other nodes in the cluster. And Elasticsearch provides several benefits of replication. It's some kind of improved availability, better disaster recovery as well, and reduce risk of data loss. Pretty the same flow as I mentioned before in the beginning of the slide. Let's move on. One more component of ELK stack is Logstash. When we are talking about Elasticsearch, we are talking more about some kind of framework technology that can store data, that can provide us a lot of possibility to search within this data and work with this data in proper and faster way. But in most of the cases, when we are using Elasticsearch, we are working with raw data. What does it mean? Raw data is a lot of data that don't include a lot of, let's say, valuable information. And to work with all this data, with all of this raw data in more proper way, ELK introduce, not ELK, developer introduce Logstash. It's an intermediate step between our source and destination that we are using this data. Basically, Logstash is an open source like Elasticsearch, like Kibana, or anything else, because ELK is some kind of Apache product. Data processing pipeline that ingest, process, and transform data from various sources. It could be logs, files, databases, before outputting the data to one or more destinations, such as Elasticsearch or a file. Also, Logstash provides us a wide range of input sources, including file-based input, network-based input, it could be plugin-based input or some kind of custom inputs as well. Also, Logstash provides a wide range of filters for processing and transforming our data, including grok filter for extracting structured data from unstructured log files, date filter, parsing manipulating with datetime values, and some kind of geo IP filter that enriching data with location information. When we have some location information, we also can use Logstash to filter out information that we don't want to work with. Also, Logstash provides a range of output destination. The main output destination for Logstash is exactly Elasticsearch, but also it could be files, it could be emails, and any of the messaging system as well, like Kafka, like ActiveMQ, for example, or any of also cloud technology and cloud services. Basically, why do we need Logstash? We need Logstash just to filter information that we're reading from source between sending it to destination. And how it looks like, how Logstash works. As you can see on this picture, on the left, we have sources. What could be the sources? It could be Amazon CloudWatch, it could be any type of files, also it could be unstructured files, it could be bits. One more additional component of our Elasticsearch, of our ELK stack. It could be any kind of system logs, and it could be streaming data like Amazon Kinesis, or it could be Apache Kafka. And Logstash provides us a pipeline that have inputs, filters, and outputs components, let's say. And on the right side, we have our destination. We can store this data directly to Elasticsearch. We can use any type of cloud storage, like Amazon S3, Google Cloud Storage, or maybe Azure Blob Storage, etc. It could be relation, non-relation databases. As example, you can see MongoDB. Also, it could be any type of files, for example, CSV, or it could be anything else. And it could be some kind of cloud services. Here, as an example, you can see SNS. What does it mean, these steps of our pipeline within Logstash? Inputs, filters, and output. Inputs combines our data into smaller chunk, and this chunk can be filtered. The filter step includes some process that can aggregate in some way or filter out information that are not relevant for our purpose. What it could be? For example, we are analyzing click streams, let's say. We are working with customer clients information, how they are working with our website. And click streams means that system analyzes all information about how many time and how exactly mouse is working within the website. And this information, very a lot of information, and we collect everything of them. But to not slow down our system, we don't want to send to Elasticsearch some information, for example, in case the mouse don't move anywhere. We just want to store information about clicks. That's it. Where customer clicks, how often customer clicks, and for example, to which part of our website. In this case, within the filters, we can apply some mechanisms that will be filtering out all information that are not relevant to our purpose. We just send to output the information about clicks. That's it. And in this case, we can reduce the data from the source between sending into destination. And outputs, we combine all our data after filter phase and send them to our, let's say, destination. For example, Elasticsearch, let's say. Good. Let's move on. The one more components, it's Kibana. Here I showed some interesting, let's say, dashboards from Kibana, how it works, how it looks like. We also will have possibility to see all of this part of dashboard within live demo. But let's talk about some theoretical parts of Kibana. What is Kibana? Basically, Kibana is a data visualization and exploration tool for Elasticsearch that provides user-friendly interface, creating and charting visualization and dashboards. By the way, when we are talking about Elasticsearch, we can use Elasticsearch in using different another third-party vendors or technologies. But Kibana as a source can use only Elasticsearch. It's some kind of, let's say, cooperation within ELK stack. Also, Kibana provides a wide range of visualization types. It could be line charts, it could be bar charts, heat maps, some geographical maps, as well as more advanced visualizations like time Leon or something like that. And I already mentioned about it, but Kibana provides flexible and powerful query language. It's called Kibana query language. It's very similar to SQL, but with some kind of specific things here. This query language allows users construct pretty complex query and filter for a data exploration and for analytical purpose. Kibana also provides wide range pre-built dashboards and visualization for various use cases, such as infrastructure monitoring, security analysis as well, and business analytics. Let's talk about dashboards in Kibana. Dashboards in Kibana can be customized to display data in a way that is most useful for a particular use case, using pretty wide range of visualization type of widgets. As you can see here, we can show our data as a map in case we have some information, and we can, let's say, proceed with data and showing within the map. For example, we have some information about, let it be orders. And within this information, we have some columns that allow us identify the city where this order made. In this case, we can show all of this information on a card, on the map, for example. And also we can visualize a number or maybe some kind of bar charts as well. These dashboards also can be shared with others to provide visibility into data and system performance, and can be exported as PDF files report for offline or let's say analysis or sharing. Let's say you are working with Kibana, with Elasticsearch for business purpose. You have all information about what happened with your business within the last a couple of months. And you can download all this information as a PDF report and take a look into this one, for example, in a trip when you are on the airplane, or in case you don't want to stop automatically refreshing this dashboard. For example, this dashboard is using for a couple of people or for a couple of departments, and you need the snapshot of your data only for now. You just do this PDF reports and you work with PDF reports, and you are sure that this data will not change. Also, Kibana provides a wide range of pre-built dashboards for various use cases, such for infrastructure monitoring, security analytics, business analytics. We already talked about this, but let's talk one more again. Bits. What does it mean, bits? So instead of we have Kibana, we have Elasticsearch, we have Logstash, and it's working in this mechanism. Logstash is filtering this data, parsing it, send it to Elasticsearch, and Kibana is using data stored in Elasticsearch as a source to visualize this data, to build some reports and dashboards. Bits help us to ship this data. For example, it's also open source data shippers that you install as agent on your servers to send different type of operational data to Elasticsearch. Bits can send data directly to Elasticsearch or send it to Elasticsearch through Logstash, which you can use, parse, transform the data. Why do we need it? We can group and ship some type of specific information. For example, in case we have different informations that could be used for different purpose, we can ship this information using bits in single parts. Let's say it could be log bits, and send this part to Elasticsearch. It's some kind of container that combines needed information, and we can work with this information pretty easier using this stuff. Cool. That's pretty it that I would like to share with you regarding some overview and introduction to these pretty powerful tools. But let's talk about some conclusion. First of all, ELK stack is powerful tool processing and analyzing large volume of data in real time. I would also add here one more point between processing: store, processing, and analyzing. We are also storing the data in the Elasticsearch cluster. Elasticsearch core components of the ELK stacks and provide search indexing capability for storing and retrieving data. Logstash, as you mentioned before, I mentioned it's used for ingestion, processing, and transforming the data between sending to Elasticsearch or any other, let's say, systems. Kibana provides web-based interface. It has graphic user interface for visualizing and exploring the data itself that stores in Elasticsearch. ELK stack highly configurable and customizable. In case we need to, let's say, configure our cluster for our own purpose, we can do it. There are a lot of possibilities to do that. And they allows users to build data pipelines, meet their specific needs and requirements. Also, ELK stack is used by organization across a wide range of industry for various use cases, including log analysis, security monitoring, business intelligence, big data analysis, or some kind of hybrid solution as well. By using ELK stacks, organization can gain valuable insights to their data and improve decision making and derive business value. Basically, in case the corporation, customer, or some kind of industry understands that how and in which scenarios they could use their data, it would be very helpful mechanism to increase the business and do more and do better. Basically, that's it. about theoretical parts, and I would be happy to answer your question if someone has.
Yeah, we have some questions in our community chat. Let me open them real quickly. Yeah, the first question is yeah, I'm showing it in our screen. Is it possible to use Elastic FTS in parallel with RDB and use SQL?
Basically, it's possible, but it's more related to how many data and say what's the resources that you have right now. You can use it pretty easily in case you're having not so much data and you have just one not Elasticsearch class. But in case you have a lot of data, some big data, I would say, and your Elasticsearch contains of a couple of nodes, 5 or more, it would be pretty hard to work with both RDB, MS, and SQL and Elasticsearch at the same time.
Okay, I hope that answers the question. So if not, please post another question in the chat. And next question. Next question is following. How big can be documents in your presentation? Looks like small JSON.
Small JSON, yeah. So basically, it's just a sample just to show you that we are working with document as JSON files. But document inside Elasticsearch can be pretty bigger. From my point of view, if I remember correctly, I had a chance to work with Elasticsearch that stores documents, store information about some kind of log analysis, and this log analysis had around 3,000 of elements inside this JSON. There are no such kind of restriction about the number of elements inside document or maybe side of this document. It's more related to resources that you have.
Okay. Yeah, the next question is in our chat. How are the shards determined?
Determined. Let me remember what does it mean. Yeah, it's let me explain it. Shards is a portion, physical portion of our index. In case we are talking index is a logical part, and one index contains a lot of documents. For example, it could be thousands or millions of documents, physical parts, and we can divide our index into, let's say, 5 shards. And in case we have 1 million of documents, each of shard will contains around 200 of documents itself, and this shard can be distributed across the cluster. One shard can be stored in one node, another one in, let's say, second node, and it also helps us to provide high availability and fault tolerance.
Okay, thank you. Yeah, that's all for questions for now. If you have anything, you can just post. Do you have anything to share?
Yeah, so feel free to share more questions in the chat, and I suppose we can move on to the live demo. Let's see how exactly ELK works, how it looks like. For this purpose, for demo purpose, I will be using Docker. I already prepared some kind of Docker images. For now, we would use only 2 containers, 2 images, one of Elasticsearch, another one for Kibana. We will not use Logstash for this purpose. Docker run Elasticsearch container. Let's run it, and one more would be for Kibana. And what you can see here, we are taking 7.11 version. It's some kind of stable version. By the way, we already have 8 version of Elasticsearch, but for this demo, 7.11 would be enough. And let's open our Docker desktop, and we can see that for now we are running 2 containers. Elasticsearch container and Kibana containers. When we open it, we can see some logs that it's running. Kibana not started yet because she's waiting for Elasticsearch to run it up. And it's starting. We can see some logs here. And let's wait when the Kibana will start. And here we can open graphic user interface. It's located inside for localhost and the port 5601 here. As you can see, we already have up and running our Elasticsearch and up and running our Kibana. What we can do now? We can start by adding our data and exploring it and building some dashboards here. We can click on Add Data or Explore on my own. Let's add some data. For adding data purpose, let's disable this one. We have a lot of data sources here, built-in data sources. What it could be? It could be audit logs from Linux audit daemon. It could be Apache metrics, ActiveView metrics, logs, Azure, AWS, also Kafka logs, etc., etc. It's some kind of pre-built data types that we can use for our purpose. But also here you have pretty interesting and cool stuff called sample data. And using this sample data, you can ingest the data for discover Elasticsearch possibility and Kibana possibility by your own. Here we have 3 types of sample data: e-commerce orders, flight data, and sample web logs. Let's start with flight data. Let's click on adding. That means that we add this sample data in our Elasticsearch for storing. And also we are already created index, and we already can use this data for analytical purpose using our Kibana dashboards. Let's open view dashboards here. It's working. It's grabbing the data, and here we have pretty nice graphic user interface with information about flights, global flights dashboards that are using open source data. And what can you see here? We can see fly logs, the information that already imported. We can see some kind of map here. It's interesting tool, and we can maximize panel, for example, and see information. It's clickable, it's searchable, and we can see, for example, information. We can also zoom into it. We can see information about some flights that doing, let it be Rome, Italy. We can see flight count 7, minimum flight time, some kind of this. But this information for last 24 hours, 1 day. And we can specify what information we can see. And when we update our filter, when we update our, let's say, what we are currently looking for, our Kibana dashboard will automatically refresh and grab new data in a couple of, let's say, moments. Let's here we have flight number for June 14, 7. Let's open June 1st, or let it be June 3 because it's Saturday. Click update. And here you can see that we have a different number. It's already 50. Let's minimize this panel and This one. Okay. Yeah, this one. And check what else we have right here. We have some information about total flights. Let's add more data here. So let it be not only 24 hours, but information about 1 week. And here we have 6 months. Oh, it's not week, and let it be 1 week. Take your date. Yeah, for now we have more than 2,000 of flights. We have information about airline carrier. Here you have possibility to click customize, or it should be some kind of edit, but it's not editable here. Let's find in other way. Overview. What we have on the graphic user interface? We have overview. We can create canvas. We can create maps for machine learning and another stuff. Also here we have discover. What does it mean discover? It's data itself. We can see what data currently stored in Elasticsearch. It's pretty powerful tool because here you can see in some period of time how many counts we have. And for example, we would like 1 week. No, 1 week. Let it be 1 hour. Yeah, we can see what data we are having for last 1 hour. And here in this period of time, we have 3 count. We just click on it and we see what exactly information we have. Let's open it. We can see it as a table, all information, all our columns from our document, or we can click on JSON and see the JSON as well. We have information about flights, destination country, original city, destination airport, and another information that could be valuable for some reason. And also on the left side, you can see all information from our JSON, from our document. For example, if you click on destination, we can see the informations about distribution of this one. Let's open more information here. Let it be relative. Let it be 16 days. Click on updates. We will have a lot of information. And when we click on destination countries, we can see that, for example, 21% was destination to Italy, 15 and more for US, and another one. And also we can click visualize. And here we have some default portion of our dashboard. We can click on different level and see these numbers and add it to the dashboard. Also, when we open dashboards, let's confirm because we don't save our changes. Let's confirm changes. Customer temperature, inspect. We can customize our data, let's say, add more things, change the color size, change the size, etc., etc. All of them are configurable. And here is one more powerful tool. From one side, we can filter our data using time period. On the other side, we can configure and add one more panel, for example, to search only flights based on original city and destination city. Let's say that we would like to see only flight from Barcelona. Apply changes, and all our dashboards, all our charts is updating based on this filter. And you can see that here we have different numbers. Total flights for starting from June to up to today is 36, and etc. etc. And here you can also see the destination was the origin and was the destination based on this filter. Yeah, I suppose that's enough from demo purpose. Let's close this one. and open our presentation. That's it for today's session. No, this one. Yeah, I found it. Thank you so much for joining. Maybe another question someone have.
Yeah, we have some other questions. The first one is additional for the last that we discuss.
Okay.
About shards determining. I mean, when index is set to shard B instead of shard A, what algorithm or strategies is being used?
Okay, let me read it once again. Index Y sent to shard B. So basically, I would not say that index sent to shard B. We will have index, it's a logical part. But when we add more document, when we send documents to the index, based on our configuration, we will add this document to some shard, A or B. In case we are working with index and would like to apply sharding, Elasticsearch using its own algorithm to, let's say, decide to which shard store this or that documents. It's more about where this document stored itself. Let's imagine a situation. We have 3 shards, and we have 3 nodes, 3 physical nodes, 3 inside class. And we decide that we need to, let's say, create 3 charts within this index. And Elasticsearch will create index A in the node where we have more data and store more documents and store this document to this index. Another index will be created on another node and store that information, the documents that are stored in these physical nodes, etc., etc.
Okay, I hope that answers the question. So, if it's still unclear, please post maybe another one question. Some more questions, or maybe it's like more a comment about about the size. Looks like the largest allowed document size is 2 gigabytes. Yeah, and here is the link you can check. And by default, the limit is 100 megabytes. So you can comment on it.
So regarding document size into gigabytes, to be honest, documents, it's one element, it's one records. I never heard about some portion of the data that are, when we are storing it in JSON format, will be received to gigabytes. About default limits in Elasticsearch in 100 megabytes, not sure, to be honest. I never faced any of limitation of Elasticsearch before. Maybe some version of Elasticsearch has this limitation. I am sure that in any cases, any of technology will have some kind of limitation, but I didn't hear before about this 100 megabytes. Need to double check it.
Yeah, at least we have the link shared with us, so we can check in
Yeah, sure. Perfect.
using this link.
Thanks for the link.
Yeah, and the last question. Hello, is it possible to store track a history of dashboard forms? How the dashboard looks?
If we are talking about data itself, we can create some snapshot in Elasticsearch and store it somewhere in the external storage. If we are talking about dashboards, we have possibility on Kibana to create a clone of our dashboards, and let's say we are creating some clone of dashboards and rename it from original name to some kind of backups, and restrict the access to this dashboard just to keep this information, let's say, without changes, and use another dashboard, another portion of data, and provide mechanisms and change it. In case we need to return back, we can restore these changes from the previous versions that we already stored in a separate dashboard.
Okay. I don't see any questions, any other questions in the chat, so I think we can close our session. Thank you everyone for joining us today. Thank you for your questions, and thank you, Marianne, for your presentation and for sharing with us this information. I hope that we will have a chance to use it, and yeah, thank you.
Thank you everyone for joining. Hopefully the session was interesting and helpful for all of you. Thanks again and have a good day. Bye.
Thank you. Bye.